So in question 12, we've been given a figure that shows the trajectory of a golf ball that has been hit from a platform until it first hits the ground. Now, on the y-axis, we have our vertical height here in h, and in our x-axis, we have the the horizontal distance traveled by the ball. We've been given three pieces of information. Firstly, that the ball is initially hit from a point on the top of a platform that is 3 meters above the ground. So that's this point here. The second point mentions that the ball reaches its maximum height after having traveled a horizontal distance of 90 meters. So that means that this maximum point here occurs at a horizontal distance of 90. We don't know what that maximum distance is yet. That is something that we have to find out later on in this question. And then thirdly, we've been told that the ball reaches a vertical height of 27 meters above the ground after having traveling a horizontal distance of 120. So if we assume the point to be somewhere around here, we see that the horizontal distance is 120 and that the vertical distance is somewhere around here, which is 27 meters. So in part A, we've been asked to find h in terms of x. Now, we can do this by using this piece of information here, that the graph is modeled as a quadratic function. Now, since the graph has been modeled as a quadratic function, well, we can use the general equation for a quadratic, which is h is equal to ax squared plus bx plus c. And now all that's left to do to find the model is to find the individual values for a, b, and c respectively. Now, if you remember from the first point of information, we've been told that the ball was initially hit from a height of 3 meters. That means that when the horizontal distance is 0, so x is equal to 0, h is equal to 3. So we can substitute both of these values into our generic equation to get the following. So when h is equal to 3, so 3 is equal to so h is equal to 3 when x is equal to 0. So that means that we have basically a times 0 squared plus b times 0 plus c is equal to 3. 0, this is equal to 0, and this is equal to 0. Hence, we know that c is equal to 3. So that's all well and good. We can substitute this into the equation. So we now know that h is equal to ax squared plus bx plus 3. Now that is our first step done. Now, for the second point, it was told to us that the ball reaches its maximum height at a vertical distance of 90. So that means that the maximum height, or the maximum point of the graph, is reached at x equals to 90. So from that, we know that if we were to differentiate this equation, that differential would equal to 0 when x is equal to 90. So if we go ahead and differentiate h with respect to x, we find 2ax plus b, and all we have to do here is substitute x is equal to 90 here, so x is equal to 90, and we would get 180a plus b. Now this would obviously be equal to 0 since it's a maximum point, and this thus yields our first equation. Now, using our third point of information, it was told to us that the ball reaches a vertical height of 27 meters after having traveled a horizontal distance of 120 meters. So that means that when x is equal to 120, h is equal to 27. So if we go ahead and input this into our general equation that we found here, so we know that 27 is equal to a times 120 squared plus 120b plus 3, which is the value of c that we calculated in the first point. We can go ahead and simplify this further. So we have 24 is equal to 14,400 plus 120b. If you wanted to simplify this further, divide the whole thing by 24, you get 1 is equal to 600a plus 5b. And that thus yields our second equation. Now that we have two equations here with a and b, we can solve them simultaneously to yield each of their values. So if I go ahead and just create a box here to help with my working out, I have one equation which is 180a plus b is equal to 0, and also another one that is 600a plus 5b, which is equal to 1. So from the first equation, I know that b is equal to minus 180a, and I can substitute this into this value here. A plus 5 into minus 180a is equal to 1. I can expand this further to make 600a A minus 900, A is equal to 1. A would thus be equal to minus 1 upon 300. Now, we have a value for A. All we have to do is substitute this into one of the equations that we have before. So let's choose the easiest one. So if I go ahead and substitute the value for A in that, I would get 180 times minus 1 upon 300 plus B is equal to 0. And this should give me the answer of 180 times minus 1 by 300, which is 3 by 5. So B would thus be equal to 3 by 5. So using these values, we know that H is thus equal to minus 1 upon 300 x squared plus 3 by 5x plus 3. And that is our final equation for the model, hence concluding part A. In part B, we've been asked to utilize the model that we found in part A to help find two pieces of information. Firstly, the maximum vertical height of the ball above the ground, and also the total horizontal distance traveled by the ball from when it was first hit to when it first hits the ground. Now, for part 1, simply we have been told that the vertical height of the ball, so maximum vertical height of the ball, is reached after a horizontal distance of 90. So we know that if that the maximum height of the ball is reached at a point where x is equal to 90. So all we have to do here is substitute this value into the equation that we found. So if I go ahead and do that, then all I have to do is, well, I have the initial equation. So h is equal to minus 1 upon 300 x squared plus 3 by 5x plus 3. All I have to do is substitute it in. So I get minus 1 upon 300 times 90 squared plus 3 by 5 times 90 plus 3. And this should yield the maximum height, which is 30 from this calculation, 30 meters. So that is the first part of the B part done. For the second part of the B part of this question, all we have to do is find the total distance traveled by the ball. And essentially that is the point at which the graph hits the x-axis. As you can see, that would showcase the total distance. So all we have to find is the point of x at which h is equal to 0, and hence is essentially the root of the equation. So if I go ahead and do that, it'll be as follows. So like we said, we have the equation h is equal to minus 1 upon 300 x squared plus 3 by 5x plus 3. All I have to do now is find the point at which h is equal to 0. So I just equate this to 0. So I have 0 is equal to minus 1 upon 300 x squared plus 3 by 5x plus 3. Now, so to solve this, you can either use your calculator or the quadratic formula. It doesn't really matter, but you should yield the two values of x to be 184.87 meters, and also x is equal to minus 4.87 meters. Now, since we are talking about distance, we can cancel out this negative term here, as distance cannot be negative. So we know that the total distance traveled is equal to 184.87 meters. But be careful, the question has asked us to provide it to the nearest meter, so we have to round this up to 185 meters. And that concludes part B. Now, in part C, we've been told that effects such as wind or air resistance are two examples of limitations to this model, and we've been asked to come up with one other limitation. So typically in these questions, you have to sort of use your ingenuity. So anything basically that would be different in the real world compared to a mathematical model is a legitimate answer. For example, in this model, we've assumed that the ground is flat. If you see, the x-axis is completely flat. But if you've ever thrown a ball up a hill or down a hill, you know that the ball may travel faster, or may travel sorry, not faster, further, or may travel a shorter distance. Also, another assumption may be that the ball may not follow a completely quadratic path. It's not necessary that it may follow this parabolic shape, and so that is another limitation. So again, with these sorts of questions, just use ingenuity, and any sort of answer that would differentiate a mathematical model from the real world is legitimate. Okay, so that concludes question 12 for this paper.